Start recording. We're recording. So we were just real quick before class talking about cross product, and you can do a formula kind of like this, where you have u1, u2, u3, so that's your first vector. v1, v2, v3, that's your second vector, and then here you just kind of do your ijk components from the formula at the bottom. I just kind of like just copied them, and so this would be your cross product right there. And you could just change your variables. So like say I got an 8 and a -1 and a 2, and then all of a sudden there's my new cross product. Boom. Super fast, super automatic. Good for an exam, even for the homework. Um, so yeah, that's just another version. Anyways, the idea today was that we were talking about the stuff you want to talk about, right? So you tell me what homework questions and all that stuff, and I already have one to talk about if that's okay. So I'm going to pull it up. So in 12.5, number whatever this is, what is this number? 9. It should just say right here, question 9, right there. Like, what's wrong with them? Silly. So yeah, there's nothing terribly crazy about this one versus another one. It's just the fact that like when we're going through it, the answer is not there, and then you have to simplify it to get to it. Let me pull up a white piece of paper and just real quick, kind of like do a little bit of this, just so that I can kind of show the folks at home, right? So we got a plane containing the intersecting lines. Okay, is that a cross product in the end? Right? Or are we gonna have to cross product to get to this stuff? Like, okay, we got a line, we got another line, and then they want the plane for that, right? But the plane is represented by that normal vector coming up out of it, and that's the cross product. So if I can find like my slopes for these two lines, then I can cross product, and boom, that's going to be my plane. But what's my slope for the first one? 3. Keep going. Yep, yep. So those are my slopes. I guess you can call that like your u vector, and this will be my v vector. So now the next one, my slopes. Perfect, perfect. And so I'm going to cross those to get my whatever number. And again, let's use Desmos to do this one. Since I have it up, now I can kind of like test it, right? See if it actually is handy to me. So 3, 1, -3, and then the second one was -4, 2, and -2. So then my answer should be, without any math, which is kind of nice once in a while, this guy right here. So that's my cross product. I think what's going on is that this will be the line, the slopes, the normal vector representing this plane that we're creating essentially. So let's go look for those numbers for the answers, if that makes sense. So 4, 18, and 10. That's going to be my answers. 4, 18, and 10. 4, 18, 10. 4, 18, 10. So we're down the right road. Okay. Now, what I need is to find the last number, right? So what we have right now is 4x, 18y, 10z is equal to blah. Now, I don't really know which one it is. How do I find that thing out? What do I do? Do y'all remember, or do you want me to just say it?
Oh, I know how to do this because I did it yesterday. So how they do it in the work through the problem thing, they first set up as x equal to x, and then solve for s, and then plug it into one of the y's equation with s to find t, and then plug that in to find both t and s.
That is complex. Yeah, you are plugging it in essentially. Long story short, you're plugging it in. But and I know exactly what they're doing. What they're wanting to find is where these points or these lines are intersecting one another to get this point P right here, which is 100% for sure on the plane. I like it. It's great. It's a great idea. But like the plane is also containing this point over here, and this point 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 here, and like any point on any line should do it, right? So to make it faster, I'm hoping this will work. I don't really know if this will work. I'm hoping so. What if I just say t equals 0? Just like whatever. Or s equals 0, right? That's going to make a point, some kind of point that I don't really care about. What if I made t equals 0? What would I get? Yep, and 1. Yeah, right. Very good. You got it. This is my X, Y, and Z. I literally am going to plug those in, and hopefully I get the right numbers. I should probably be able to do this, right? 2 times 18.
I believe that's 36.
I'll take it. Come on, math majors. We can do this. And you're like, no, I'm engineering. What is it?
32.
32 for reals?
Or just 42.
42. I'll take 42. Okay. So looking here, do I have a 42? And that's a no, I don't. But what's interesting though, right? It's like it's divided by 2, but not quite. What do these all 4 have in common? All 4 of them. Divisible by 2. So they're not giving me one of the answers up there. It should be a 2, a 9, a 5, and a 21. Do we have that one up somewhere?
Yes.
Bam. So the bigger idea for this question was, I can't see my answer. What's going on? It's because they simplified to get one of those answers. So, they're trying to be tricky, essentially. Cool. Okay, y'all show me more. Tell me more. I'll jump to it. Any section, any question. Yeah, let's do word problems. 12.2, let's do it. 12.2. Question. You tell me which one. That's a fun one. Airplanes. 16. Oh, yeah, these are terrible. These are so terrible. And we didn't cover one in class, see? That's why we're doing this kind of stuff here. Because, obviously I can't cover everything. I wish I should have probably put one of these in there, though, because it's a good one. All right, let me clear this up. And let me draw. Okay, good. So, if you've had physics before, this should be no problem. But then again, even in physics, it's a problem. Who in here's had physics again? Really? No? You're the only one? With Rabani? You did this then. Many times. I know, it's a classic problem. But let's go through it. Let's figure it out. So we're wanting to know how much weight's going on. I'd rather draw this in my own little way. So I've got 3 forces coming from this single point here. And this is W, but not just W. I want to say that it's 0, W, because it's going down and not side to side. And even further, not just W, but what would be even better? Negative W, because it's going down, isn't it? Technically. And you don't have to do this. I'm just showing one way to think about it. W goes down. Four? Okay, look, I'm trying to draw a 44 down here. Wouldn't it be 44 down here? So this is 44. We all had to learn geometry at some point. And this right here is 31. I think the 31's easy enough, but I need to know not this angle, but the other one. I need to know this angle here. And how do I find that? Yep. From 180. Yep. You got it. 180 minus the 44. Yep, you're right. Good. So I'm subtracting them. 150, 156? No, yeah, no. Sure. Whatever you say. I don't know. I'm just the math teacher. So 136. I wanted to get it the I guess angle from 0, right? Unit circle stuff, and that way I can do this problem a lot easier. So to get this angle over here, it's F1, and they said they don't give me F1. Okay, that's fine. So I'll just go ahead. Yes, that will definitely come in handy. So what I'm going to do is I'm going to just call it f because I already got a w. So then I'll do it f. I'm going to do f cosine of 136 and then f sine of 136. Because again, it's just the x and y components in that direction. Cosine, sine, x, and y. And then for the last one, I'm going to change my color here on this guy. So for this guy here, that's just 30. So that's kind of easy. Again, though, they gave it to us, like you said, so it's 50. So I got 50 cosine 31 and 50 sine of 31. So basically, I need all my three vectors to just kind of all mush together and be the same. Be equal to 0, essentially. And so let me write that out. I guess I could just do this here. So I got f cosine 136, f sine 136, sine 36. And I'm going to say plus, and then I got 50 cosine 136, 50 sine. What am I doing? Whop, whop, whop. Wrong angle. Wrong angle. What do I have over there? 50 what? 31. 31. That was my bad. But you see, like, you can go through the whole math and you're like, where am I not getting the right answer, right? Because I wrote it down wrong, you know? And then finally, 0 and then negative w. And all this should be 0 vector. Again, you could just say 0, 0 either way. The main point, though, is that I'm trying to line them up. I keep going for the highlighter. I don't want that. I'm trying to line them up so that I can say all of these, right, are equal to 0. And then all of these are equal to 0. I'm wanting to just say all my x's and all my y's are equal to 0. And then after this, we'll have a lot of math, of course, but that's the setup side of things. Yeah, go ahead. Yeah. Yes. Right. Right. Yeah, definitely equals 0. Static, because it's not moving, equals 0. Very good. That's right. Yep. True. So now we got to do the math. But are y'all okay with the setup? Good? Yeah, good. Did I do it okay? Did I do it up to Rabani level? I know he does. I know he does. Yes, he's got different formulas and stuff. He has a lot of different ways of doing it faster. Oh yeah. Oh yeah. No. I always do like x colon, and then this is what I normally do when we're doing the real math. 50 cosine 31 plus 0 equals 0, right? Something like this. Yeah, this is the math finally now. Am I doing Rabbani style now? Okay, perfect. Okay, yeah, there you go. Rabbani style. And definitely true. That's very good. We will have to do it like that now. Yeah. So, but right, we're just writing it out. We're just trying to make it look like all my x's, all my y's, and I'm just copying them down. So I'm gonna erase at the top, and then that way I have a little bit of room. You would think I'd have a bigger eraser, but I'm on Edge actually. Yeah. So you can blame Microsoft. So let's just look at the first one. I'm going to write a little bit more clearly. We got f cosine plus 50 cosine is equal to 0 essentially, and I need to solve for f. And I think that's easy here because there's nothing else, no other letters. So what do I do? Yep. Yep. And then divide by that cosine. Very good. Start over. Nope. Keep going for the highlighter. Don't want the highlighter. So yeah, f would be equal negative 50 cosine 31 divided by cosine of 136. Why did I put co 31? There we go. Calculator. Yeah, let me just make it bigger because Okay, I'll keep that up there. So yeah, negative 50 cosine 31 divided by sine of 136. We are in degree mode, so I've got a negative 61.697. Thank you. If I were taking the test, I'd probably not pass it, but that's why I would look it over and add points. Yeah. Okay, there we go. Right. Getting a negative value as an indicator is something messed up, right? I mean, it happens sometimes, but it's not. A negative would be pushing. It'd be pushing the block rather than pulling the block, right? So, yeah. Okay, so we got that answer. Sweet. Now we can go on to this bottom one down here. So then my F is the 59, so I'll say 59, 5801 sine. And I got the 50 sine. And I got minus W is equal to 0. This one's easy, right? I'm going to do A and S to make that faster over there. Let's do that. Sine of the 136 plus 50 sine of the 31. Okay. Right. Yep. So then W would equal 67.1397. Again, that's in newtons, isn't it? All this is newtons. Okay. I want to see if it's right before we actually say, good job, Chad. So 15, oh no, they're wanting W first? W. That would be 61.14. No, they're going to want 3 decimals. Okay. Oh, wait, I have my answers right there on the side. What am I thinking? 67.140. 3 decimals. Okay. And then my F1 was the 59.580. Sweet. Okay, we got it. Woo.
One thing I find funny is if you solve the whole entire problem before you think of, what's F1, and stuff like that. Instead of like, hey, is F1 this or that? They're like, hey, solve the whole question first, and then we'll tell you if you're right or not.
Oh.
That's like how Lewis time.
I know. Yeah, I'm understanding.
Yeah.
And I have to get F in order to get W, so why didn't... Yeah, I know. Yeah. That's the way it should be. Anyways. Cool. Good? Good? All right, give me another one. I'm here for you guys.
There was one section 3.
Okay. Is it a word problem?
I'll pull up my computer real quick and I'll
Sure.
let you know.
Okay. If any of y'all have another one in the meantime.
Ask questions and participate as well.
Oh, well, they're listening. Leave a comment in the leave a comment for me in the comment section. Yeah.
Like and subscribe.
Yeah. Make sure to like and subscribe my videos. That's funny. There's another one. I'm here. James is going to take his time on it.
Hey, I'm sorry, I'm trying. Okay.
Yeah, no, you don't have to rush. We got other problems we could do, right?
Go over just like 12.5 basics. Just the basics of 12.5. No particular question.
So like you want me to go back to the workbook kind of thing?
Yeah, just like review that real quick.
Sure. That's easy. Yeah, lines and planes. Oh yeah. So lines and planes are interconnected. The line is just a line through space, but a plane is defined by a line. That was a terrible line. Hold on. It's gonna look better. I gotta make it look pretty. There you go. So to define a plane, it needs a line, and that line is called a normal vector. So we call it like n or something like that. This is what I would call the slopes of that plane. So they're kind of all together in this section here. You're doing math magic, okay? So like the overview is that we need lines in order to make a line and also to make a plane. So that's the bigger overview. We had those formulas, of course. The style that we for formulas of the plane. All three of these are good. You could see that we did our initial points, and it set equal to 0. Or like the last one, well, the first one we did today, we just said, hey, solve for D, right? And this is kind of that same style because I'm plugging in a point, right? I'm plugging in a point to solve for D. That's kind of what's going on there. But if you had a point, you could just do this, set it equal to 0, and then you're good. More formulas. Yeah. Sure. I'm fine with that.
I just don't want to trip you up in case you go right on the board.
I'm no, I yeah, I'm tethered exactly. I could talk more about it if that's good. I mean, it's good.
That's good.
Good.
We'll have a break review of the part that is
Sure. Sure.
later on today.
Oh yeah, yeah. Another problem, I can do it. Word problems, I'm okay with that. You find it, and I do it. Did you got it now?
So my computer randomly shut off, so I wanted.
Okay.
Yeah.
Yeah, still free game. You got something? No, it's good. I want to do it even if you haven't tried it. Which one is it? Perfect. Let's go back to 12.2. Let's do it. Yeah, let's do it. 15. I love it. I mean, like, even if it's the same question again and again, I'm super happy to do it because I'm here for you guys, you know? I guess resume. 15. Beautiful. Let's do it. So this one, you don't like this one? Oh no, even worse. I love it. Let's do it. Yeah, this is great. This is beautiful. Oh yeah. Oh yeah, for sure. Yep. Um, so we. So this one here, because they told us the weight is 0 and -50. So that one's not too bad. They say F1 is this guy. Now, this would be my alpha, right, down here. And so then how do I get my true angle? So when I go and do this, my F1 is 36. So I'm going to say 36 cosine of 180 minus alpha, and then 36 sine of 180 minus alpha. It's the same thing, just sine and cosine, you know. This one's not too bad. So my angle here was a 60, so this is the 60. So then F2, I don't have an F2, so I just call F cosine at 60, F sine at 60. So those are my three different vectors, and I have to mush them all together, equals 0. Whew, here we go. So let's do the x's. I'm just going to skip to the math part that we need. 36 cosine 180 minus alpha plus F cosine of 60, and then plus 0 equals 0. And then for the y's. Same thing. Should probably put a little degree symbol up there. Cosine 60. Nope. What am I doing cosine? That's wrong. Sine. And then minus 50 equals 0. The last time we had this, I was able to solve for 1 because it was really easy and then plug it back in. This one, not so much. We've got 2 different variables going on at once. So in order to find this, I'd have to, I guess, solve for f, plug it back in, solve for alpha. But did it say to use a calculator? Well, I'm saying to use a calculator. So this one's crazy. I don't want this one on an exam. This is not a good exam question. The other one is a great exam question. This one's not, because again, we're having to use a graphing calculator. So, okay, not having to, but I'm wanting to. So real quick, let's just get the answer, right? So graphing calculator. And I'm going to put both of these guys in. One thing that we have to remember is that here, it's all, and I have to use X and Y if you don't mind. Let me use X and then Y. It almost looks like an X. Y. The problem here is that it's all in radian mode, if you remember how this works. In graphing, you have to have radian mode, which is... You can? No way. I'm gonna definitely do that. Hold on. Because I definitely don't want to have to change everything to radians. Oh, that would be terrible. Do they have that? More option. Bottom. Oh man, that's so nice. Thank you. Yeah, so if over here, degrees. Oh wow, so much better. Oh my gosh. So yeah, and we're wanting to know where they're intersecting. So there's a couple options there. We want things that are all positive because that angle is a positive and our forces are all positives. Let's try that. I want to see if that'll work. That would be really cool if it's just that easy. Let me do that. Yeah. Okay, so alpha, click. There we go. Alpha was the 76. 2 decimals. 76.02. Nice. Okay, then we're definitely down the right road. I don't want this on the exam. It's not a good exam question. Does it make sense? Like, you've taken exams. Do you want this on your exam? You tell me. No. Well, I guess if you could, that would be better. But I mean, it's not a good test for what we've been doing. This is just a crazy question. So yeah, I would recommend just stopping here, doing that, because if you want to do it by hand, you'd have to figure out arc sines of something, and it's not fun. Nobody wants to go down that road. It's not what the class was designed to do. Are we okay with that? Good? Excellent. Very good question. Did you find yours finally?
No, Matt, the CTC Wi-Fi is being a pain in
It's a
the butt.
constant struggle over there. I'm sorry, bro. Show me another one, guys. I'm here for you.
CTC getting quite wrong.
I don't know. I don't make those decisions. Y'all tell me. I go anywhere, do anything. I do the same problem 3 times. I don't care. I'm happy with it. Depends on the class.
Wasn't there some sort of equation that I can get you where 1 equals 0? But it deals with like pi e's and all.
Then 1 plus 1 can be less. Yeah. Show it to me. Which one? 12.1, last question. Gotcha. Let's do it.
Yeah.
Super excited. Yeah. I mean, if you're sending me something, please, I would love to have it for everyone else, because that way we can all figure it out together. And I did create this homework, but I mean, it has been a couple months, so I can't remember all that. Yeah, yeah, let's talk about it. This one's weird because it's like, what are they asking for? There's got to be some kind of trick, like in order to find this kind of thing. So I'm gonna draw. I'm gonna draw a picture and kind of just talk about it. Do this, something like that's fine. Okay, awesome. So we have a sphere, which is like a ball. I'm just gonna draw a sphere, kind of like this. And you could do something kind of like this if you want to make it like fancy, I guess. But we got a ball, right? And they're saying there's a point out there, and and the XY plane. I just jumped right to the point. Okay, so let's talk about the point first. There's a point somewhere out here, and they're saying somewhere on this ball is a point that's closest to that other point. We'll call that one Q, P and Q. So where's Q located, right? And what if my point P was up here? Then the closest point would be right here at Q. Um, the happy thing about this particular problem is that it's not wonky like that. It's actually right above or below it, or on the side of it. And so let me demonstrate. Notice that we have it not centered at 0. So the circle is centered at -4x. So 1, 2, 3, 4, 0 for y, and -8 for z. So we just go down. -8, 1, 2, 3, 4, 5, 6, 7, 8. So it's down here is the center of the sphere. And its radius is only 1. So it's just a tiny little thing down here. Right? Little circle action down there. Cool? Cool. Where is this point? I want to talk about the point. So let's use a different color. No. Draw. Okay. It needs more room. It needs to be bigger. There. No, wait. I want a color. Okay, cool. Color. Green. Anything. So -9. Let's do -9. So -9 is this way. That was -4, right? So 5, 6, 7, 8, 9. So we're there. 0 again, and go figure, -8. So it's just down here. You can see that what's going on is that they're like almost right next to each other. They're separated by this distance right here. This distance right here is the same distance from the center to that point. Cool? Okay, so like graphically, are you kind of seeing where we're going there? Awesome. But they're wanting a point that's closest on the sphere. So like it would technically be like on this side of it, and it would be wanting to talk like this small little distance. But we know that the radius of it is only 1. So if I did this, and I'm going to like make this a shadow up here, if this was my center, then that circle shadow would be like that. Like if I just had a bright light and I shined it, and that would be my shadow for that little ball. And so, and this is my point, and so you could see that like it's just this small little distance here that we're talking about. So how much distance we got? 1, 2, 3, 4, 5. A 5 distance. So in a way, I want to go like 5 distance back so I can hit that edge of the circle. And so that's my answer in a way. I'm just saying wherever I was, I'm going to go back 5. Or you can just say wherever my center was, I'm going to go 1 forward, 1 this way. So my normal center was -4, 0, -8. But then let's call it edge. What's ever on the edge be a -5, 0, -8. Because again, the radius is only 1. Or you could have said, I went back from -9. I'm going to go back 4 because there's only 4 distance in there. And then you would get to that guy, I guess. Either way. So that's my answer for part B. Yay! But I didn't even look at the part A. I was like, who cares about that stuff? So I'm going to do a different color here. The XY plane is this entire plane up here. right? It's like this big piece of paper. And I'm saying, hey, where's the closest point to that? Well, it's on top of this thing, right? It's right here, and we would just go straight up to hit that piece of paper. So it's like basically the same point again, but now I'm instead of going x, what distance, what direction am I going this time? Z. So I'm going to go -4, 0, -7 because I'm only going up one. Radius is only one. That's my point for this one here. Let's just check it out. Let's just see if this is making sense. And again, it's almost better if like I'm going to try Desmos. You know what? I'm going to try Desmos 3D graphing here in a second to see if that would make it better. One of the harder hang-ups is that I think I draw great because I see what I'm drawing in my brain, and then I'm just, I see what I'm drawing in my brain, and yay, that's the greatest picture ever. Can't you see the Mona Lisa? And so, like, that's in my brain. It looks great, but y'all are trying to translate, right? And it's hard. I'm not the best artist. I don't know if any. Maybe I'll take drawing lessons. I've tried, of course, but hey. So let's do some Desmos 3D and see if that makes sense. 3D. So I'm gonna like literally just put that equation in. I think it accepts those kinds of equations, right? Did you try? Good, good. And that is exactly how you should. You should graph it and see like what the heck are you talking about, bro? So yeah, let's zoom. Let's do this. I don't want that. Can I like do that?
Those double arrows just where you close equation on the bar.
Bar.
Where you put equations.
Oh yeah.
Those double arrows next to the top.
Oh, thank you.
That also works for graph. The regular.
That looks so cool. It looks like the sun and planet Earth. Right? Here. So let's look at it from right here. Yeah, that's perfect. See? So now that's the XY plane. So this is where its center is, and this is where we want to be. So if I no, can I like move over some? Ah, I'll figure that out later. But so right here is -4, and that's -5 would be the edge of the circle. -6, -7, -8, -9, right? So where on the circle is it closest to this dude is right here at -5, essentially. That's all we're doing. We're just changing the x a little bit. Cool. How do I represent the XY plane in here? How do I draw XY plane? Well, it's like it's right there. I know, that's a good idea. I should just take that at face value. But like honestly, it's z equals 0 is the XY plane because again my z is at 0. Well, it's not going to do that anyways. So go ahead. Oh look! If I zoom into my circle, then it does something like that. Yeah. Wonder if I could do more grids. That's just too many numbers. I can't do it. So, anyways, I want to know like on the top here, all the way up. So it's like right here. Again, this guy we said was at -8, so that one must be at -7. But I really want my grid to be a little bit different. No, maybe minus, plus, 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 minus, minus, remove, remove. Stop rotating. Okay, yeah. Why is this not liking me all of a sudden? Oh, 0. I gave it a radius of 0. My bad. It was a 1. It was a 1. Okay, there we go. I was just wanting that Z axis to be a little bit more ticky. Yeah, I know. There's too many numbers. Okay, cool though? Pictures? Mm. Yeah, so that's, see how it's touching? So that's my 7. Yep, that's true. Okay, you have it?
I finally found it.
Woo! Let's do it then.
Question 12 on section 12.3.
12.3, let's do it. Is this annoying to y'all, having all these things up here? Yes? Thank you. I'm so sorry. It was no other great way to do it. 12.3?
Yes, sir.
Perfect. Okay.
I wonder if they have a way of organizing it so that it can be like set up by
No.
notes.
No, it's my math lab.
Okay.
Sorry.
Question,
I asked. I really did. Okay, which one?
question 12.
12. Let's do it. Yeah. So a vector is parallel to this line. Equation that P is parallel to V. Draw a sketch of the line. Draw a sketch of the line.
Yeah, that's part B.
U, including V starting at the origin. So the equation of the line. Oh yeah, okay. We could definitely do this. Give me 1 second though. I need to drink something, and I'll just have some coffee. So that's what we have. No one's drinking my coffee.
Every day I make good large pots.
No one takes my coffee. Last semester, it was sucked down twice. Every day, I'd have to refill that thing twice, and now I don't. Well, like the 7:30 class, normally they're the ones, right? But then they don't want it. I don't know. Right. Yes, yes. Okay. First, as always, I'm going to start with a picture. Okay, so we have a vector. This is a 2D vector, which is nice. 1, 2, 3, -2. And so this is my vector. I want to redo that right quick. Erase that guy. Draw my vector. So there's my vector V. Okay, so 3, -2. Easy enough. Make that look a little bit better. And then I have a point at -3, 4. So let me do that in a different color. So we got -3, 2, 3, +4, 1, 2, 3, 4. So this is my point P. Okay. And they want a line that's parallel to this, but starts right here. Cool? So what would that even look like? Well, it would look kind of like this. I mean, I know that I'm trying to make them practically the same, but it's not perfect. Try one more time here. Parallel. It's not that they're touching one another. That's not the point. It's just that they're both going the same direction. Like this basically will keep going forever. It doesn't really matter. So minus AY is equal to C. I don't know if I trust it personally, but it's fine, I guess. If I have to do it their way, I don't want to do it their way. I don't want to do it their way. Do you mind if I do it my own way for a second? Slope is, let's go fun slope. Y'all are calculus students. Look at that, right? Do y'all remember some derivative action? None. Oh, you don't have to do any of that. It's basically just y over x, right? So I got my -2 over my 3. So that's kind of like my slope from right here, right? Y over x. I made it look fancy though, didn't I? And y'all are like, don't make it look fancy. I don't want that. And then we have a line equation. Y minus y1, m, x minus x1. This is just algebra stuff, right? So my y1 is a 4, -2/3. X minus the -3. That's a plus. I'm going to distribute. So that's a +3. The 3's cancel, but that's a negative right there, so I think it's going to be a -2 in the end. Add 4 to both sides. Now, there. That's my line equation. I want to see if they accept it. I mean, obviously, it's not in their fancy format. Okay, so they want it in a different format.
Yeah, it one that I tried that I got wrong. It wants it like with my problem is x plus 2y equals 5.
Yeah.
One to equal number.
Exactly. But this is how you make a line. I'm just going to remind you. This is the good stuff. Continuing on from where I am, they don't have fractions. We're not going to want fractions. So I'm going to literally multiply everything by 2. And so that would be a 2y is equal to negative 3x plus 2. And they want both the x and y on the same side. So I'm just going to move that over. So I got 3x plus 2y is equal to a positive 2. And I want to try that. So that's just moving things around to their liking. What? Did I mess up? Yeah, I did, and I didn't. Ah, you're right. This right here should be a 4. Because I multiplied everything by 2. I just said that. I didn't. Thank you. Okay, hold up. It's pretty close. Would you give me credit? That's pretty interesting. I wonder what's going on here. Yeah, I didn't actually do what they did. Did I? Oh, you're right. Look, it says 2 over 3, and now it's 3 over 2. Oh, and then if I multiply by 3, I would have got a 6. I want to throw something. Okay, so I messed up right here. Like, then look, perfect time for highlighter. Oh, it's not, oh, there we go. That was the problem. That was my problem right there. But look how easy that is, right? Look, I'm being not live stream. I'm being recorded. I'm your teacher. I'm freaking out all of a sudden. Oh my gosh, Lord. Well, this is why we write down our work so that I can just literally flipped it. Everything else would have been fine. Okay. Old algebra style, that kind of stuff. But is there way quicker? So let's see. I got bx minus ay is equal to c. And I'm assuming the b and the a are from here. I'm assuming that this is a, this is b. So let me just try that out. Negative 2x, and I got a negative 3y is equal to something I don't know. I'm going to plug these numbers in. And I want to see if I get what they got. That's a positive 6 minus 12 makes a negative 6. So I got 2x, negative 2x minus 3y is equal to negative 6. And I guess what they just did is said all positives. And then did I get what they got? So much faster too. So maybe I should read directions. That's okay. That's okay. But I mean, in a way, I want to revert back to old algebra, right? Because I know it. I'm really solid with it. We've done it so long. I know what a line equation is. You don't need to tell me. But then, yeah, what they do is easier. Picture. So my vector was going down. It's one of these guys. For sure, one A or C. Oh, it has to be A. You're right. It said parallel. This is the only one that is parallel. Huh. Man, read directions indeed. Look at that. That was funny. Cool. We got time. We got 5 minutes. Show me. Tell me something. Let's go. I got this. I'll get it wrong for everyone. This coffee's really good. And we have 8 cups left, at least. I know, it's really good. I make it every morning. Give me a problem.
There's one. I don't know if we have enough time.
Yeah, of course we do.
But in 12.4,
Let's
we
do it.
start doing vectors with W with three vectors instead of two. And I was kind of curious on if we could review over that.
Yeah. Got a question for me specifically?
I think question 9.
9. Oh, this guy?
I think it may have been before that, maybe question 8.
That one's an easy one compared to this guy. He's nuts. Do you want him? I could just roll with it. Number 6. This guy?
Yes, that one.
Let's do it.
That was first. It actually was.
You're good. You're good. Yeah. So there's a formula for the volume of a parallelepiped, and it's like you cross 2 of them and then you dot one of them or something. I had to write it down, didn't I? Because it was in the book. Is that correct? Didn't I write that one down on it? Yeah, that was a write down thing. I think though it's cross product and then you dot it with the other guy. Okay. Now let's do that. If I still have Desmos Scientific, it should be pretty fast actually. So let's redo this. And I don't think it matters which one you pick first, second, or third. So I'm just going to roll with whatever I see. So 3, 1, 0, cross 4, -1, 3. And I'm going to say all the stuff dot, and then 3, 0, 3. Very good. Very good. Let's find this guy first. And again, I could do it by hand, but if I have that Desmos still up, it should be going pretty fast. Desmos Scientific. Yeah, look at that right there. 3, 1, 0, 4, -1, 3. Then my answer would be 3, -9, -7. Notice that my 7 here, I put a little slashy through it because it looks a lot like the alligator symbols, the little vector symbols. Just like you've probably seen me do X, Y, and Z with a little slashy, because this looks like a 2, right? In Calculus 3, you start doing these techniques so that you can, not mess up. Because I messed up a lot, obviously. So 3 times 3 is 9. I got a 0. So like I'm just matching them up. And then I've got 7 and 3 makes it -21. And so this guy here is negative. Scientific. We got a scientific calculator. Probably. Okay, thanks. But it's the magnitude of all this stuff, right? So 12 is technically the answer, I think, unless we have to divide by 2. I can't remember. I think that's a triangle. Okay. So yeah. Cool. Right. See, that was good. So we only have the 1 minute left. Are y'all okay doing this again? Is that a good thing? Bring more, or are we done and we want to just move on? How about if you find something, bring it. If you don't have anything for me, then we can move on. Your call. Good times. Was this fun though? Was this good? Good. Okay. Cool. Thank you guys.